Hello and welcome to another video. In this video we're going to be working on buy two chocolates, and you're given an integer prices representing the prices of various chocolates in a store. You're also given a single integer money which represents your amount of money. You must buy two chocolates in a way that you have some non-negative leftover money. You would like to minimize the sum of the prices of the chocolates you buy and return the change you'll have after buying the two chocolates. If there's no way for you to buy them without ending up in debt, return money because you can't buy them. So the leftover must be non-negative. So let's go over the examples. In the first one, you would just buy these two, and then you would have zero change. In the second one, you can't buy two of them. And so this is kind of pretty much, it's like a greedy problem essentially, right? But the solution's kind of straightforward, where you're basically asking like, how much change will you get after buying two chocolates? And can you buy them? And so the optimal solution is pretty straightforward to find. You're just going to want to find the two cheapest chocolates and buy them, right? Because if you can't buy them, you can't buy anything else. So essentially your algorithm is going to be something like have this kind of array, look for the two cheapest things, and see what the total is. And there's a few things to do this. So what we could do is we could just initialize two variables. So we can say like small and big maybe, right? Like small be, or we could say like cheapest or whatever, right? Like first, second, and so on. We'll just call it small and big. And we'll make them both infinity because we are trying to minimize them. So we'll make them both infinity. You could also make them the first two items. So we'll make them infinity. And pretty much what we're going to do is we're going to go through our number and we're going to check, is it less than the big number? And if it is, we want to check, is it less than the small number? Because ideally we want the small number to be the smallest one, and we want the big number to be the second smallest one. So we're going to check first, is it smaller than the big number? And if it is, we'll check if it's smaller than the small number. And if it's smaller than both of them, then what's going to happen is the small number will get replaced by it, and the big number will get replaced by the small number. So let's walk through how this is going to go. So in the beginning, we will check, is 8 smaller than our big number? Yes. Is it smaller than our small number? Yes. So we will replace our small number with 8. And we'll replace our big number with our old small number, which was just infinity. Then for 5, we'll do the same thing. Is it smaller than this? Yes. Is it smaller than this? Yes. So we'll replace the 8 with a 5, and we'll replace this infinity with the old value of small. That way we can keep track of both of the two smallest numbers. Then we get to 3. So is 3 smaller than big? Yes. Is it smaller than small? Yes. So we replace and replace like this. Get to 3 again. Is it smaller than big? Yes. Is it smaller than small? No. So we just replace the big number. Then we get to 2. 2 is smaller than both of them, so we'll replace small. And the big will be the old value, small, which was the same. Then 9 is too big, 4 is too big, 6 is too big, 3 is too big, and 2 is less than big, but it's not less than small, so we'll just replace like this. We'll get our two smallest numbers, get a total. And this is the least amount of money we can spend, so we just check, like, do we have enough? And if we have enough, we'll return 1. If not, we'll just return the money. And that's pretty much it. So that's all we have to do. So we're essentially just going to keep track of two numbers and then add them up at the end and see if we have enough money to buy the item. So let's code it up. So we'll have small, big, make them both equal to infinity because we're trying to minimize. And we'll go through these. So for price and prices, if price is less than big, let's check if it's less than small as well. So if it's less than both of them, then we want small to be the price, and we want big to be the old small. So small will be the price, and big will be the old small. Otherwise, if it's less than big, but it's not less than small, then we just want to replace big. So we'll say big equals price. That'll give us the two smallest prices. Then we just check for the total. So we'll say like change equals small plus big. So it's actually going to be money minus both of these things, right? So we have some money. We have to buy these two candies. This is how much they cost. Then we get a change. Then we simply return the change if it's non-negative. So we can say return change if change is greater than or equal to 0. Otherwise, let's just return money. And that should do it. And there we go. So pretty efficient solution, pretty easy. And you can do this with a bunch of numbers. You can have like 3 numbers, 4 numbers. I think we had a problem like this where we had the smallest 2 and the biggest 2. This one's even easier. You only need the smallest 2. So for the time here, it's going to be pretty simple. O of n, right? 1 pass and space Oakland. And I will point out that someone literally wrote like a 10-page editorial on how to do this, so this is kind of funny. They wrote a 10-page editorial on basically how to do 2 plus 2. So props to whoever did that. I thought that was kind of hilarious. But yeah, if you did like this video, then please like it and please subscribe to the channel. And I'll see you in the next one. Thanks for watching.